Hey guys, so we have started to learn about identifying equivalent algebraic expressions and how to write them using parentheses, not using parentheses, talking about the distributive property. Now we're going to dig a little bit deeper into combining like terms within these algebraic expressions. So first off, we're going to do a little bit of vocabulary review. A term is a number variable or the product of a number and one or more variables. So that is called a term. We have learned that from our past lessons. Terms can only be separated by a plus, or minus sign. Okay, plus or minus sign only. And then the identity property of multiplication is also listed below. So 1 times x equals x, and x times 1 equals x. So whichever way it's written, they both will equal the same thing. Okay? Which we also kind of talked about yesterday as well. So we simplify algebraic expressions to get rid of the parentheses and combine like terms. Okay, so those are the two things that we look at. We want to get rid of those parentheses and we want to combine like terms the best we can. So I'm going to do a sample problem in the far right boxes step by step, and I want you guys to follow along with me as well. So we're going to do, let's do 2x plus 3 plus 4y plus 2 minus x plus 7y. Okay? So step 1 tells us to identify like terms. We want to box like terms and circle terms that are unlike the ones we boxed. As I talked about yesterday, I use different colors because I'm on my whiteboard or I'm doing this through the computer. You can use different shapes. If you have pens and you want to be organized and do it that way as well, you can totally do that. So in this box, I'm going to start by writing my expression. So I have my 2x plus 3 plus 4y plus 2 minus x plus 7y. So I'm going to choose my color for the x values, okay? For that x variable, I see one term here, 2x. That's one term that has an x variable in it. I see one here, a minus x. Notice that I included that minus sign in front of the x. That's very important, okay? So then I'm going to move over to my next one. I see a 3. Circle that. And I see a 2. Those can be combined. And then I see a plus 4y plus 7y. Okay? So step 2 tells us to rewrite the expression with variables first and constants last. So I'm going to start with my x values first. So I have 2x minus x. Then I'm going to move on to my y, plus 4y plus 7y. Then move on to my constants, plus 3 plus 3 plus 2. All right, so step 3 tells us combining groups, those like terms. So we're going to combine with what we circled above or whatever you squared above. You're going to combine the like terms. So I write it one more time, 2x minus x plus 4y plus 7y plus 3 plus 2. I'm going to use the same colors that I used previously just so you can see the visual. So my x values, I'm putting parentheses around them. Okay? Let's see, the y is green. My y's, putting parentheses around them. I'm grouping them like terms. And then I have my constants. Okay? So then I solve each section. I solve the like terms to combine our groups. So 2x minus x gives us x. Remember that an x by itself, right here, this x here, means 1x. So you can put a 1 in front of it if you'd like. That means 1x. Okay? So 2x minus 1x gives us an x by itself. I bring down that plus sign that's in between the parentheses here that comes down. 4y plus 7y. 4 plus 7 is 11y. Bring down, I have another plus sign here. And then I combine 3 plus 2 to get 5. So that is my simplified algebraic expression. And I'm going to circle that, big letters. I know that that's my simplified algebraic expression. All right, so this technique involves multiple steps. It involves being very organized, keeping everything in line so that we can get to that final result. All right, so I'm going to go ahead and erase and scroll down. If you need to rewatch this section, if you need to pause and go back, feel free to do so. I'm going to erase and scroll down now. Okay, so as we've kind of said, like terms are terms that have the same variable. So we have 2y and y. Those can be combined because 2y minus y gives us 1y. They're both y's. Okay? And then as we've also been talking about, just another note for you here, a variable with no written expression. Here, let's do a variable with no written coefficient. No written coefficient has a coefficient of 1. So go ahead and highlight that sentence so we can remember that. No written coefficient has a value of 1. Coefficient of 1. And then it shows you over on the right or on the left-hand side an example. X plus x equals 3x. Because we have 1x, 1x, and 1x. Okay? So below I have example 1 and example 2 that kind of walk you through step by step of what we need to do. So because I printed this for you, I simply underlined and highlighted my different like terms. So I have 3x and minus 2x that are common terms, like terms. I have plus 1 and plus 4 that are like terms. All right, so that's my step 1 here. I boxed my terms, I separated them, and then my step 2, I moved my variables to the front and I grouped my like terms. Okay, and then I do 3x. My 3x minus 2x to have 1x here. And then 1 plus 4 gives me my 5. And we have a plus operation sign in between those two because we have a plus from above. Okay? Example 2 over here, we have 4x plus 5 minus 2x minus 2. So I group my 4x minus 2. I group my 5 minus 2. I end up with 2x when I subtract 4x minus 2x, and 5 minus 2 gives us 3. All right. So now I'm going to do some practice problems with you. Practice number 1, I want you to pause the video right now, do practice number 1, and then continue the video to check your answer with mine. So go ahead and pause. Okay, so now that you're back, you should have solved practice number 1. I'm going to go over it with you now. So I see 4z minus z plus z minus 2z. These are all like terms because they all have the z variable in them. Okay? So just like any other order of operations, we need to solve one step at a time. So I'm going to underline 4z minus z. That's what I'm solving first. 4z minus 1z gives me 3z. Plus z minus 2z. I'm drawing my z's like that so that you can tell that they're z's and not 2's. Okay? So then I go next step. 3z plus z. This is 1z, so that gives me 4z minus 2z. 4 minus 2 gives us 2z. Circle my answer. All right. When I look over at example or practice number 2, we have, let's do yellow. We have some n variables, and then I see some constant numbers. So I'm going to highlight all my n's, all my variables that are alike. I'm going to rewrite my expression with the variables first, constants after. And I'm going to group them. So I have 1/2 n plus n plus n plus 2n plus 2/3 n grouped. And then I have plus 1/2 plus 4. Okay? So I have a lot to do here with my n variable. There's many parts to it. So I'm going to start with my 1/2 n plus n. That gives me 1/2 n plus n plus 2n plus 2/3 n. Okay? I'm going to combine all of this in one. I see that this is 1n and this is 2n. So I'm going to add 1n to 1 and 1/2 n. That gives me 2 and 1/2 n plus 2n gives me 4 and 1/2 n plus 2/3 n. Okay, so from here, I need to find a common denominator in order to continue solving, correct? Yes, we cannot add fractions without a common denominator. So I'm going to turn this into a mixed number. So I have 9/2 n plus 2/3 n. I'm going to find a common denominator of 6. So that's times 3 times 3 gives me 27/6. Times 2 times 2 gives me 4. 27 plus 4 gives me 31/6 n plus what's over here. Don't forget about that. That's 4.5 plus 4.5 to get my final answer. So practice number 3, I'm going to have you do on your own.